read this question again, it asked us to find out where something is defined. And then it also asks us to simplify. So a reminder of what simplifying means. We had this in grade 10. We want to write it as a mixed radical. So our powers chart that we wrote the other day is going to come in handy. A couple of other things that we're going to need to remember from the other day is, what is the square root of x squared? Close.
Real x,
X. I like that. Flap your arms and say x, and then I'll accept your answer. What is this? What is this thing again?
The
Absolute value of x.
X.
Also flail like a bird, x. There we go.
I'll do that in the next test.
Should I remember it from the test?
If you do that on the test, you might be inadvertently cheating, right? Because someone else could be looking at you and like, oh, I have to remember that.
Question.
And he's at the back of the class.
That's right. So.
Pretty protected.
Unless someone's fine.
It's the absolute value of x. Okay, so in A, and I'm going to talk a little bit about notation here, because for A, square root of 45, we're going to go to our powers chart and ask ourselves, can I break up 45? And because it's a square root, I'm looking at powers of 2. Is there a perfect square, 4, 9, 16, 25, 36, 49, that divides 45 nicely? 9. It's 9 times 5. So I could rewrite, because our rule for multiplying square roots says you can multiply them together, so I could break this up this way. And then what is the square root of 9? 3. Square root of 5 I can't simplify anymore. What's the square root of a squared?
Absolute value of x.
Oh, I was looking for a bird flail, but that'll be good. Absolute. The absolute value of a. Somehow I prefer, they have this as the answer. I always like writing my square roots last. So I think I would probably write it like this. But you have to have that a in absolute value bars. Okay. Now, this worked out nicely. As far as showing work, this worked out nicely for A, but it causes a little bit of problems in B. Okay? Oh, and we never said where it's defined. Look at that. We highlighted it and then forgot to answer it. This is often the case when you're doing a math question. You forget something in the question. That's why it's really important to reread a question after. Is there anything that's going to be bad to plug in? Can you find things that work? Can you find things that don't work? Like 1 works, right? Can you find something that doesn't work? No. No matter what you plug in, works. So where is this one defined? Everywhere. Positive numbers work, negative numbers work, 0 works, everything works. For B though, let's do the defined thing first. In B, it's a square root. Can't square root negatives. There's a negative inside. So first you might think it never works. But can you find a value of B that you could plug in that makes it work? What works? Negative 1 works. Because if you had negative 1 to the power of 9, it would still be negative. And then times that negative 27 would become positive. Do you see that that's true with any negative numbers? So as far as this being defined, as long as B is negative or equal to 0, you're going to be fine. Now I'm going to show my work like I did in A, and I'm going to run into a little bit of a problem. Okay? So, can you break up 27 with a, it's going to be 9 again, right? So it'd be 9, it's negative 27, negative 3, and then b to the 9, I'm going to break up with b to the 8 and b. Because if you square root an even exponent, it's going to be fine. However, if I show my work this way, I have a problem. Even though this is just my work, I just wrote square root of a negative number, which is never allowed. So, oops. Instead, this is how I'm going to recommend us showing our work, unlike we did in A. Just make one big square root and break things up. So negative 3, b to the 8, and b. And then you can think about which ones you can square root. Like you can square root 9, so that comes out in front as a 3. What happens when you square root b to the 8? Exponent laws. Does it make sense that b to the 4 times b to the 4 is b to the 8? What's your rule for multiplying exponents? Add the exponents. So square rooting b to the 8 will just be b to the 4. You do not need flappy bird marks here. If you put them, it's not wrong. But why don't we need them?
Because it always comes out positive.
Because b to the 4 is already positive, so, and if absolute value makes something positive, and you already know it's positive, it's kind of redundant. So it's not needed. Does that make sense? Like b to the 4 is already positive. If I put those absolute value bars there, I'd make a positive number already positive. It's redundant. So it's not necessary. If you look at the answer at the bottom of the page, they didn't include it there. But this can be confusing for students. They're like, why do I include it sometimes and why not other times? We have to say, well, in this case, it was already going to be positive. And then what am I left with? I'm left with inside the negative 3, and I'm left with the b. And since b is less than or equal to 0, that's okay, because that would make the inside positive still. Okay, part C. We've got the 4th root of 7z. And we need to figure out where this is defined. Can you think of some that work and some that don't work? Positive works, right? What about negatives? Negatives won't work because it's an even exponent, an even index. Can't be negative inside, so negatives are bad. So z has to be bigger than or equal to 0. And now we simplify. It's a 4th root. So you have to look at your powers chart on powers of 4. What's 2 to the 4? It's already 16. You're not going to be able to simplify 7 at all because it's too small. If you're going to simplify a variable, do you see that your exponent would have to be at least a 4 to pull one out? So, don't you hate it when they do questions like this? This is already simplified. It's like those factoring questions where they say factor. You can't get it, and you can't get it. And you look at the back of the book finally and you say, what's the answer? And it's like, not possible. I just spent 10 minutes trying to get this, and you tell me it's not possible. I just spent time trying to simplify it, and it was already simplified. Wouldn't that be terribly mean? I give you a quiz, 25 questions. Each question says simplify, and they're all simplified already with that.
Well, the main thing is finding one that fits.
And then you start to think, what do you put one of them that isn't? It's like, should that be illegal? Am I like technically performing psychological experiments on my students?
Cruel and unusual punishment for act.
And D, we've got a cube root now. Oh, cube roots are nice because anytime it is an odd index for the defined part, super easy. Everything, because you can cube root negatives, you can cube root positives, you can cube root 0. As far as simplifying this goes, now we're looking at our perfect cubes. Is there a perfect cube that divides 24? Yes. It's 8 times 3. And every time I have y cubed, I'm going to be able to pull out a y. So cube root of 8 is 2. Cube root of y cubed is y. Do I need absolute values? No. Absolute values only with even indices. Square roots, fourth roots, sixth roots, eighth roots. And then we still have our cube root of what's left inside is just the 3. So circle questions 10, 11, and 14. And I'll give you some time to try those.